Okay, this is the final video for Unit 5. We're talking about ions, ion formation, ionic bonds in this unit. So now we're talking about something new. It is polyatomic ions. So far we've talked about ions that are made up of only one atom, and those were monatomic. So monatomic ions were things like Na plus, Cl minus, N3 minus, O2 minus. But now we're talking about polyatomic ions, which are made up of more than one atom. So they're composed of more than one atom, but they function as a single unit. And that's an important idea. These ions are called polyatomic ions. So poly means more than one. Poly is a prefix. And atomic referring to an atom. So more than one atom. Usually, polyatomic ions are molecules that have a positive or negative charge. So it's a molecule that's acting like an ion and gets stuck in an ionic compound. Ionic compounds that have polyatomic ions will follow the same general rules for chemical names. Remember, the cation comes first, the anion comes at the end. The difference is that polyatomic ions have specific names that must be used. It's important we do not refer to the individual atoms that compose a polyatomic ion. So one example that you'll see we'll work with on example 10. NO3 minus. So this is a nitrogen with 3 oxygens attached to it, and it has a -1 charge, and so all of this is going to act like an ion. This is an example of a polyatomic ion. But this has a name. Its name is nitrate. We don't call it anything other than nitrate. It's not nitrogen oxide, it's not nitrogen trioxide, it's not anything crazy like that. This is its name, it's nitrate. Chemical formulas will also follow the same general rules when we have a polyatomic ion. But there are a couple of more specific rules that exist for some circumstances. So a particular polyatomic ion always has the same ratio of elements. For instance, this nitrate always has 1 nitrogen, it always has 3 oxygens. So we can't change any of the numbers in the formula. They are stuck the way they are. If we have more than one of a given polyatomic ion, we will write the formula unchanged within a set of parentheses. And then we place the subscript outside of the parentheses. So let's say we had a compound with 2 of these nitrates, it would look something like this. The NO3 goes inside the parentheses unchanged, and so if there's 2 of them, here's the subscript. And so this tells me that there are 2 of these nitrates, and the nitrate is 1 piece. If you only have 1 nitrate, the parentheses are unnecessary. The extra subscript is not going to be there. All right, so let's look at a few examples here. So if we have a compound that is sodium ions and nitrate ions. So nitrate, as we've already discussed, is NO3 with a -1 charge. So here's the NO3, here's the -1. So same idea with the switching of the charges. So we've got this sodium and this nitrate. This one has a 1 plus, this one is a 1 minus, and we just swap them. So this 1 means that we're going to have 1 nitrate. Since it's a 1, we're just going to leave it off. We'll just put a 1 here for now so we can see it. The -1 charge for the nitrate means that we have 1 sodium. And so when we rewrite it as the actual chemical formula, the charges are gone because now this compound has a net charge of 0. So any charges should be gone. And these 1s will basically disappear. And so we're going to end up with NaNO3 for our chemical formula of sodium nitrate. So let's look at what happens if we have magnesium ions forming a compound with nitrate ions. So nitrate is -1. Magnesium is in group 2, so it's going to have a 2 plus charge. So this negative charge really means -1. So switching the charges, this 1 comes here for the magnesium. This 2 on the magnesium charge will become the subscript for nitrate. And then we're going to have to rewrite it. So we have 1 magnesium, so the subscript just disappears. The fact that Mg is here implies that we already have 1. So this subscript of 1 won't show up. Then we have NO3. We have 2 of them. As it's written right now, it looks like I have 1 nitrogen and 32 oxygens. This is not good because I actually have 2 of these nitrates. And so remember, we have to use parentheses. We need to put our polyatomic ion inside the parentheses, and then the subscript goes on the outside. So now what this is telling me is that I have 2 of this nitrate polyatomic ion. So here is our final formula for this example. Similar ideas. So if you look at iron and nitrate, nitrate always has a -1 charge. But iron is a transition metal. And so remember, its charge could be different. And so this iron is specifically iron 3 plus. And so let's go ahead and do our switching the charges method. So the 3 for the iron tells us that we'll have 3 nitrates, and the 1 on the charge of the nitrate tells me I will have 1 iron. Then I need to simplify it. So I've got Fe, and the atomic symbol here implies that I have 1. So this 1 is unnecessary. And then I have 3 nitrates. So we need to write it with parentheses, NO3, 3, so we can make sure that it doesn't look like I have 33 oxygens and 1 nitrogen. So here's our formula. An important thing to note, with iron being a transition metal, we have to indicate the charge of it in the name. So when we're talking about this one, it is iron 3, so parentheses, and this 3 tells me the charge of the iron. I'll put a little pink note right here. And then nitrate. For the other two, since these are not transition metals, the charge of magnesium is always the same. We can just call it magnesium nitrate. The charge of sodium is always the same. We can just call it sodium nitrate. Like that. So those were nitrates, but there are other polyatomic ions, and we're going to look at some of those now. So here is a compound composed of sodium and a different polyatomic ion that is 2 carbons, 3 hydrogens, and 2 oxygens, and it has a -1 charge. Sodium, we know, has a +1 charge. So this is going to work in all of the same ways. So let me write these two things. This is actually a -1, this is actually a +1. And when we switch the charges, it tells me that I have one of these, and it tells me that I have 1 sodium. And so we end up with a chemical formula. These ones are going to cancel out. NaC2H3O2. You'll notice from start to finish, the formula of this C2H3O2 never changed, other than when we got rid of the positive and the negative. This compound is sodium. There's the cation. This polyatomic ion is called acetate. Sodium acetate, it is a salt. It's not what we would really call salt in our kitchen. But this is responsible for half of the flavor of my favorite potato chips, which is salt and vinegar. So the vinegar is usually hydrogen with the acetate. It makes acetic acid, which is vinegar. But it's really hard to put acetic acid into a solid form. And so what they do is use sodium acetate. Acetate smells and tastes just like vinegar. And so salt and vinegar chips. Here's one that's different. So far, all of our polyatomic ions have been anions. They were negatively charged, and they came at the end of the chemical formula and the end of the name. Here is probably the only one that you'll come across where a polyatomic ion is a cation. NH4 with +1 charge. And let's look at it with Cl- chloride. So this is going to follow the same basic pattern. We have plus is really a 1 plus, the minus is really a 1 minus, and we're going to switch the charges. So we end up with 1 chloride and 1 of these NH4 polyatomic ions. Since both of these are going to have a subscript of 1, we can just leave them out. And so NH4 is unchanged, and then Cl. So here's the formula. These ones are gone, and most importantly, the charges are gone. Remember, in your chemical formula, there should not be little charges hanging out, because since these two have that positive negative attraction, there's a neutral charge here, and so there should not be charges written. This has a name. This particular polyatomic ion is ammonium, and the compound itself is ammonium chloride. All right, so here's one where we have a sodium ion, which has a +1 charge, and an SO4, which has a 2- charge. So the plus is really a 1+, and the SO4 2-. We can go ahead and switch the charges. So this 2 is going to go here, and it tells me how many sodiums are going to be in this particular compound. And then this 1 ends up over here, and that tells me there will be 1 of these SO4s. So once we rewrite the formula in a 2 and then SO4, this 1 disappears. And we don't need any parentheses, so our formula is Na2SO4. And the name of this, here's sodium, which always has the same charge, and the polyatomic ion is sulfate. When we are in class, I am going to give you a paper. It has a list of quite a few polyatomic ions, and those are ions that you're just going to want to memorize. So you won't have the paper to look off of sometimes. It's just going to be something that name, formula, and charge, we just have to commit it to memory so that when it comes up, we're ready to work with it.